So starting in this section, we're going to be using double angle identities and half angle identities. And so in the last section, I kept screaming about whatever quadrant we were in, and that's going to become pretty important now. So if I've got a double angle identity, I've got these formulas to choose from, and notice that cosine 2 alpha, I've got 3 different options. I can choose any of those 3. And it's going to give me the correct ratio. It just may be pretty soon that one out of the 3 is going to be more beneficial for us to use. On the half angle identities, we're going to have to locate what quadrant we're in first, and so that we know if it's going to be a positive ratio or a negative ratio. And then same thing here, same thing here. But I also have these 2 options down here, which will kind of sort of figure themselves out based on the ratios that we apply. So with no further ado, we're going to run in and start looking at some of these examples. So the first example we're going to do is the sine of theta. Sine theta equals 3 over 4. And I am told that 0 is less than theta is less than pi over 2, which means I am in quadrant 1. Okay, so I want to find a couple things here. I want to find the sine of 2 theta. I want to find the cosine of 2 theta. I have no idea if I'm leaving enough room for this. I have the sine of theta over 2, and I've got the cosine of theta over 2. So the cosine of theta over 2. So first thing I should notice is I've just got a random angle measure. I don't know what the angle measure is, but I do know a ratio. So I can create my triangle using those ratios, or that ratio right there. So if I go ahead and create my triangle, let's squeeze him in over here. I'm in quadrant 1. My opposite is 3. My hypotenuse is 4. So 16 minus 9 is 7. So my x-coordinate is going to be root 7. All right, so I want to look at the sine of 2 theta. So a couple things to look at is if I double an angle in quadrant 1, where is that going to land me? Why do I never know where my unit circle is? Hang on. I lost him. He's gone. Where's my... Oh, look. It was under my paper. Okay. So if I'm in quadrant 1 and I double my, what's the word? My angle, then I'm going to be stuck either anywhere from quadrant 1 into quadrant 2. So think about 89 degrees. If you double 89 degrees, you're going to get just shy of 180. But if I'm at 5 degrees and I double it, I'm going to get 10 degrees. So doubling an angle in quadrant 1 will land you somewhere in the top half of the unit circle. Okay, so the sine of 2 theta, using our handy dandy sheet, says I simply take 2 sine theta cosine theta. So I'm going to apply the formula to sine theta cosine theta and look up on in here. Here's my theta. And so the sine is 3 over 4. And the cosine is root 7 over 4. And so I get 2 over 16, which reduces to 1/8. And then I get 3 root 7 over 8. So this 2 and this 4 reduced to a 2. So that left me with 3 root 7 over 8. And that's done. So now we've got the cosine of 2 theta. So looking at the cosine of 2 theta, I want to choose one of these 3 things. And unless I'm drawn specifically to the second one or the third one for like solving equations or something like that, I'm going to go ahead and use the top one simply because I won't have to get a common denominator to manhandle that one. And I won't have to get a common denominator to manhandle that one. So I'm going to go ahead and use cosine squared alpha minus sine squared alpha. That is not a Pythagorean identity because, hang on, I can't write and talk at the same time, because Pythagorean identity adds. Okay, and we're in terms of theta, so let's make those thetas. Look at those. All right, so cosine squared of theta is going to be, what's the cosine? Root 7 over 4 squared minus, what's my sine of theta? Sine is root 3, or sorry, just 3 over 4 squared. So I get 49 over 16 minus 9 over 16. I don't get 49, I get 7, sorry. I get 7 minus 9, because root 7 times itself is 7. 7 minus 9 over 16 is going to be negative 2 over 16, which is negative 1/8. Okay, so what you just found is you landed in quadrant 2, because cosine is negative in quadrant 2. Okay, so let's take half of this angle. So again, I can choose what I don't choose, but I need to identify positive or negative. So if the sine of theta over 2, if I'm already in quadrant 1 and I chop that angle in half, where's my unit circle again? Good heavens to Betsy. He just needs to stay where I put him. If I chop this angle in half, it's going to still be in quadrant 1. If I chop this angle in half, it's still going to be in quadrant 1, and everything is positive in quadrant 1. So I'm going to grab the sine of half of this angle, and it's going to be a positive 1 minus cosine theta over 1 minus cosine theta over 2. So that's going to give me 1 minus, what's the cosine? Root 7 over 4. All over 2. That 2 is in the radical. Okay, get a common denominator. So I end up with 4 over 4 minus root 7 over 4. And then I can multiply my denominators together. So I get 4 minus root 7 over 8. And 8 I can reduce. I can break it down. That's the same thing as 4 times 2. And I know what the square root of 4 is. Just remember it's in your denominator. So that's going to become a 1/2 square root of 4 minus root 7 over 2. Okay, so again, 2 squared is 4 times 2 gives you that 8. All right, so let's try the cosine of theta over 2. So I'm in quadrant 1. I know it's going to be a positive ratio, and it's going to be 1 plus. So I have 1 plus cosine theta over 2, which is going to be 1 plus, excuse me, square root of 7 over 4 over 2, which is going to give me 4 over 4 plus root 7 over 4 is 4 plus root 7 over 4 all over 2. And then I'm going to multiply these. Where did I get my over 4s? Yes. And then I'm going to multiply those and get 2's. So I've got a 4 plus root 7 over 8. So if you'll notice, I'm mimicking what's here. It's just that one's positive, one's negative. So I've got 1 over 2, 4 plus root 7 over 2. Okay, so that is how you're going to break these down. So I'm not going to work out every single one of these for you. Let's work out one more set of it, and then you'll have video 1 done. So I've got tangent theta. Some of these rationalizations can get kind of sticky. So tangent theta is 5 over 2. And theta is less than pi, or pi is less than theta, which is less than 3 pi over 2. So I need to look at that. That means I'm in quadrant 3. Okay, because I'm between pi and 3 pi over 2. And I want to find the exact same answers that I did a while ago. So first thing I need to do is build my triangle. Good heavens to Betsy. All right, so I need to build my triangle. Sorry, and I'm in quadrant 3. So quadrant 3, drop down into quadrant 3 and come over. And so here's my theta. This is the origin. And so my ratio is going to be opposite, which is 5, over adjacent, which is 2. So 25 plus 4 is 29, and you'll have to take a root. Now I'm in quadrant 3, which means x is negative and y is negative in quadrant 3. But this ratio of -5 to -2 goes positive. So it's very important to draw your triangle and recognize what quadrant you're in. Now, if I want to find the sine of 2 theta, I'm going to use 2 sine theta, cosine theta. So I've got 2. The sine of theta is opposite over hypotenuse. So -5 over root 29. The cosine of theta is adjacent over hypotenuse. So -2 over root 29. So I'm going to get 20 over 29. A root times itself pops out. So what about the cosine of 2 theta? So again, I can choose among these 3, but I really don't want to get a common denominator. And so since my hypotenuse are the same for cosine and for sine, it's going to give me a common denominator if I use that top one. Otherwise, I'll have to generate one for here and generate one for there. So I'm going to be a lazy math person, and I'm going to use cosine squared theta minus sine squared theta. So cosine squared minus sine squared. Cosine is going to be adjacent over hypotenuse, and sine is going to be opposite over hypotenuse. So my root 29's pop out, so this gives me a 4 over 29 minus a 25 over 29, and that gives you a -21 over 29. Okay, so what is the cosine? What is the sine of a half angle? So the sine of half of that thing, first of all, I got to figure out what quadrant I'm going to land in. So, unit circle. If this is 270, what's half of 270? It's 135. So you're going to land right about here if you take half of these angles. Well, what's half of 180? It's 90. So you're going to land in quadrant 2 when you take half of these angles. Okay, so sine is positive, cosine is negative in quadrant 2. So my half angle is going to be positive because it's positive in quadrant 2. And I'm going to get 1 minus, that was pretty, cosine theta over 2. So positive 1 minus, what's my cosine? It's going to be -2 over root 29 over 2. Okay, so that's going to become, get a common denominator, so that's going to be root 29 over root 29. So I'm going to write it bigger. Root 29 over root 29 minus a -2 becomes positive 2 root 29 all over 2. So now I've got the square root of root 29 plus 2 over root 29 over 2. So we learned a while ago that I could flip, and you can't see, I could flip this to 2, from 2 over 1 to 1 over 2. So now what I have is root 29 plus 2 over 2 root 29. So you can rationalize that if you want to. I'm going to leave that thing alone, okay, because he's ugly. All right, so in order to rationalize, you would just multiply top and bottom by 2 root 29. Actually, just by root 29, but it's cleaner to do it by 2 root 29. All right, so now I'm going to do cosine of theta over 2. So cosine of theta over 2. I know that cosine is negative in quadrant 2. So I've got 1 plus cosine theta over 2. So what I have is a negative, we're going to write big, 1 plus my cosine, which was, I don't remember what my cosine was, is adjacent over hypotenuse, -2 over root 29 over 2. So this is going to be root 29 over 2, or sorry, root 29 over root 29. So I get root 29 minus 2 over root 29 over 2. And then that's going to become a negative root 29 minus 2 over 2 root 29. And then again, you can rationalize that. Just the inside, okay? You can rationalize that by multiplying by 2 root 29 on top and bottom. I cannot speak today. Okay, so that is just an intro. So we'll do some more examples on the second part.